Good morning, students. I hope you're fine and well and safe at home. So, this is continuation of the previous lessons about logic gates. We had talked about logic gates. We had talked about AND gate, OR gate, and NOT gate. Now it is the next topic, which is called a NAND gate. It is actually combination of two gates, AND gate and NOT gate. We discussed about the AND gate. What is an AND gate? AND gate is when the A and B, both inputs, are high voltage. So the result output X will be high voltage. And what is NOT gate? In the NOT gate, whenever we give high voltage, it is converted into low voltage. And when we give a low voltage, it is converted into high voltage. Okay, that's fine. So it is a combination of two gates. AND gate and NOT gate, the output X will be high voltage unless both inputs are high voltage. If both inputs are high voltage, the output will be low voltage. That means output X will always be 0 unless A and B are high voltage, yani 1. So now we discuss it how it is high voltage, how it is a low voltage. As we know that this is combination of two gates. This is AND gate here, and this is a small dot here. Small dot means it is combination of two. One is NAND gate and another is NOT gate. So and here it is a NOT gate here. As you can see, it is a NOT gate here. Here this dot will be got as a NOT gate. So whenever A and B, A and B, A is here, B is here. So whenever we give a low voltage here and low voltage here, in AND gate, whenever there is A and B are low voltage, the output will be low voltage. But on the other hand, there is NOT gate. Whenever there is low voltage here, output will be low voltage, and NOT is converted into high into low voltage. So now coming to the first scenario here is 0. We give input here as 0. Next one is 0, the low voltage, and low voltage it is converted into low voltage, and the NOT gate converts low voltage into high voltage. That's how we got the output as high voltage. Now another scenario number 2. There is low voltage here, high voltage here. When there's low voltage, there's high voltage. So low voltage into high voltage in AND gate is low voltage. But here again, NOT gate. The NOT gate converts low voltage into high voltage. That's what the truth table states about. Coming to the third point, that is low and high. When A is high voltage, B is low voltage. Again the same thing, that A yani this input is high voltage, and here it is low voltage. So high into low in AND gate is again in low voltage, but in NOT gate low voltage is converted into high voltage. And there is one more, fourth scenario, high voltage and high voltage. As we know that whenever there is high voltage in AND gate, if A and B is high voltage, so output will be high voltage. So this condition, applying this condition, high voltage into high voltage. So high voltage into high voltage is again in high voltage in AND gate, but here it is not gate. The high voltage is converted into low voltage. And logically, we can discuss this at logically. This is X, any output is equal to A NAND B. NAND is a gate name and B. And in Boolean, we can call it the X is equal to A dot B, which is a dot product. Now, let's see how it works. This is a software which is called Logisly. You can download it from the internet. So now let's have a look on this. I'm getting one AND gate here, and there is a NOT gate here. Now I connect both of them, because in NAND gate it is a combination of AND gate and NOT gate. Of course, I need some output as here, so I take a bulb here. A bulb is very a common example from the daily life, we can turn on and off 1 and 0 to get the results. So here is a toggle switches. One is here, one is here. That is basically off and on. As we know that we use the buttons on daily routines. The when we push up, it's off. When we push it down, it's on. Okay. Now both are off. As you can see there, this is low voltage, this is low voltage, and result is high voltage. Yani both are zero, both are off, and we are getting as high voltage. Yani we are getting as high voltage here. Now the second scenario. Here it is. The 0 and 1. That means A is off and B is on. Again we are getting as a result as on. Now let's see about it. If A is on, B is off. So the result is 1. Now what will happen if A is 0, B is 1? So again we are getting 1. Now the fourth scenario, when both are high voltage means both are on. Here will be on and it will convert into 0. What will happen if I give A and B input as high voltage? Now see, here high voltage, B is high voltage and it is converted into high voltage here, but it is a NOT gate. NOT gate converts 1 into 0, high voltage into low voltage. That's how we getting a 0 here. As you can see here, high voltage is low voltage. I hope you understand well. And if you have any questions, if you have any queries, you can ask me privately in the WhatsApp groups, or you can email me and you can discuss it in the group as well. Thank you and be safe, stay here.